Hello, and welcome to AMAT502 at UAlbany. I'm pleased to introduce you to our course this semester, where there are small couple changes from the past semester. I want to kind of walk you through the logistics you need in order to get started in this class. So let me just go ahead and start sharing my screen, and I'm going to give you the broad desktop so you can see everything that I see. So you should have gotten an introductory email, which asks that you make sure you download the UAlbany VPN Global Protect. You'll see that you'll need to first connect to this VPN by entering in your NetID, all lowercase, and your corresponding password. All right. Once you've done that, you should be able to refresh and see the link for our Jupyter Hub server, courtesy of the IT department here at UAlbany. This semester I'll be AMAT502 8879 Spring 21. I'm going to pretend to log in as a student. And again, the important thing is that you make sure to have your NetID all lowercase. Assuming that goes all well, you should have access to this sort of landing page for your Jupyter Hub server. You then need to click on assignments, and you should see up here released assignments. I have logged in through the administrative account associated to our server and gone ahead and uploaded lecture 1. You then need to click fetch, and you'll see it is now listed underneath downloaded assignments. If you click on this further, you can see lecture 1. This will then bring you to the lecture notebook, which I will lecture out of, and which I ask you to watch before we come to class, because after that, we're going to actually have a live notebook where we can test our understanding in a more practical way. So stopping our share shortly, I'm going to transition over to my version of this notebook, where I have additional slides software installed. So, all right, we're now ready to actually get started. So in today's lecture, I'm going to walk you through the genesis of this course and give you an idea of some of the basic things like syllabus and so on. Of course, I have a privately made link for those of you who are registered for the course, so that we can meet during our scheduled meeting time and go through the questions that are related to the lecture notebook, which I cover in these videos. Again, the steps are here. You need to make sure that you've had the UAlbany VPN installed. That is the one that takes you to this Global Protect website, which has software depending on your operating system. That's necessary to log into our Jupyter Hub server. The link, as you know, is dependent on this course in this semester. And I've listed the steps that I've just gone through here. In general, the format for this class is going to be that lectures and assignments are going to be distributed through our Jupyter Hub server. Although at times I'll probably lean on some more private services such as GitHub and Binder for lecture materials. All right. So let me tell you a little bit about 502 and its context and where it got its name from. So the history of 502 was that before I took it over, it consisted of sort of a tapas of lots of different programming languages, where we just did a little bit of each of the following. HTML, LaTeX, which is the premier language for writing mathematical symbols in a way that produces in a nice PDF. Of course, MATLAB, Sage, and others. But one of the problems was that people who took this course, although maybe it was relatively easy and straightforward, they never really came out of it feeling like they really had mastered something. And maybe I'm being a little flippant here, but I'd say that the problem was that old school mathematicians tended to teach this course with the focus on equipping either research mathematicians or mathematical educators with the basic tools they needed. Things like HTML for your website, LaTeX for writing your papers and your thesis, And then of course, maybe MATLAB or Sage to do a little bit of computational math directed at whatever research you are working on. Again, this is not to say that those things are not worth learning. It's just that nowadays the demands have shifted a bit. So this course is also now listed as part of our new Data Science Master's program, which got its start in 2017 and is starting to be refined to adapt more and more to the needs of the students that come to our university here at UAlbany. Specifically, it's completely agreed upon that everyone needs to learn Python if you want to be a data scientist. And in fact, I'd say that any research mathematician also needs to learn Python just because of how useful of a language it can be. Its use comes from the fact that Python is a general purpose programming language. So it's of course been well used and adapted to data science, but it's a broad language like C++ or Java that allows you to handle anything that you can really put your mind to. I'll also say that part of Python is a beautiful set of packages that have been developed by other people, which can help anyone, including those who are interested in mathematics education. We'll see more on that as we get into visualization later in this course. Of course, as part of any first day of class, I need to go over things like the syllabus and what books I hope you buy and so on and so forth. Now, the resources for this class, meaning these Jupyter notebooks, I think are largely self-sufficient. But that said, if this is your first time learning Python, it might be useful to pick up a book. I've used previous iterations of this book by John Guttag at MIT called Introduction to Computation Programming Using Python, which has just been released in its 3rd edition as of January 2021. I haven't yet received a copy yet, but based on the e-copy I've seen as an instructor, it looks really good. I'll also note that this was the book which was meant to model after MIT's own Introduction to Computer Science courses. So as you all know, MIT has sort of world famous computer science education, and they had completely scrapped their initial way of teaching computer science using Scheme, which is a variant of Lisp, to use Python instead. And this has led to the following edX courses, which if you need additional materials to go through, I recommend that you consult some of these. We can see that they just started another semester here. But again, the focus there is going to be slightly different and more in depth than what we're doing. But we're also going to move faster in other places because this course is for graduate students. I also want to do a big shout out for Jake Vonderplas's Python Data Science Handbook. Traditionally, when I looked at this book over here, which was for MIT, they used an outdated plotting software that just had been completely deprecated. And so Jake Vonderplas really helped me bridge that gap and teach people Matplotlib. This text has now been updated to use Matplotlib, so it'll be current if you have this latest 3rd edition. However, Vonderplas's book is also wonderful for getting into machine learning and from a practical viewpoint. You can read the book entirely for free through here, which is written essentially using Jupyter software like I'm using for these lectures here. This will be a useful reference, but also one that you don't need to spend any money on. So the course syllabus, and this was the one that I settled on for fall 2020, but which I'll now also use for spring 1. And I do that just by hitting Shift Enter, is to focus on having exercises and extended programming projects. Roughly 40% of your grade is going to be graded based on these exercises and programming projects. 30% is on a final project, which is going to be really part of you building a portfolio as a data scientist. This is going to include an individual presentation component where I see, as you present your results, how do you as an individual perform? But there's also going to be a group write-up component. So you're going to have to produce essentially something that looks like a research paper by the end of the semester. We'll get more to that as we get closer to that time. Additionally, to reflect the fact that much of this has been happening online, and for spring 2021, we're also operating online. I've decided that instead of having a graded final exam, that it's best to get people to practice their oral explanation skills. So I'll be scheduling individual one-on-one oral exams with all of you at the end of the semester, just to judge your individual coding ability and also your conceptual handling of the material. Additionally, because this is going to be a flipped class, and me and the TA are going to move through breakout rooms to see how you are getting along with the live exercises for each lecture. General expectations here are, I want you to have your video camera on and your microphone on. And I want to see you interacting and asking questions with other coding buddies that are in your sort of pod of 3 to 5 people. This is because right now learning online can be very lonely, and I want to make sure that people feel like they're not totally lost. Additionally, when I come through and the TA comes through, I want you to be able to answer the questions that we ask you, and so that you can really advance in your material, your understanding much better. Again, this is one aspect of university education, which hasn't been replicated online in things like edX and other MOOCs, where you get really one-on-one interaction with the professor. And so luckily we're doing that here at UAlbany. Finally, of course, there's going to be an attendance component. So please make sure you come to that. All right, so I will craft up our coding buddies, but the idea is that these are people you can safely collaborate with. But that'll be depending on the results of the Google form, which I haven't yet analyzed. All right, so if this lecture were happening live, I would have given you all some time to socialize, but right now I'm pre-recording things. All right, so now that we've handled a lot of these introductory considerations about syllabus and how to access the course, let's get into the actual material. So the big question, which I want people to have an understanding of, is what is data science? And there's now been a universally regarded sort of Venn diagram, which intersects all the different sort of subject matters and expertises that are necessary in modern data science. This consists of a combination of math and statistics knowledge, hacking skills, which you could think of as just developing your skills as a programmer, and then substantive, or I'll say subject matter expertise. This essentially means that if you're working at a startup which is interested in doing data science related to health data, for example, you need to know some of the latest biological literature of what goes into health. But the magic of data science is that you really need to combine all 3 of these. You need to be a capable programmer, you need to have a solid understanding of math and statistics, and you need to know the details of whatever subject you're trying to study. And if you're in any one of these sort of areas where you're in 2 but not in the other, you sort of fall into a different branch. So in machine learning, experts are going to be very good at programming and specifics for algorithms, along with the math and statistics involved there. But they're not going to necessarily know much about the application at hand. Traditional research used to just operate between combining math and statistics and whatever subject you were studying with math and statistics, and didn't really have any programming. But again, nowadays we want to have products, and that product often involves the use of programming. And then finally, the thing to really avoid is, suppose you're just hacking on a particular subject, but you don't have any solid math or statistics grounding. Drew Conway calls this the sort of danger zone. And of course, we're going to be trying to sit right here in the middle. And for this class, we're mostly going to be focusing on the hacking skills and then reviewing and introducing some math and statistics. But then as we get into the final project, I'm going to ask that you really become a sort of a miniature expert in whatever field you're studying. So just to go into a little more detail about what the expectations are for each of these sort of three areas. The assumption is that almost all of you are math graduate students. Here at UAlbany, we have the data science master's program housed within the math department with the idea that we want to be focusing on some of the fundamental aspects of data science and the algorithms that rely a lot of these methods. Things that I'll assume is that, let's say a little bit of calculus. If I want to get at, for example, how do we find the root of a polynomial? We want to talk about Newton's method. I'm going to, rely a little bit on a cartoon understanding of what is the slope of a line that passes through 2 points? What is the derivative? Things like that. Those not strictly necessary. Differential equations is sort of a nice, but again, not strictly necessary. This will become important as we talk about optimization. What does it mean to sort of flow from one sort of set of parameters that governs your model to a better set measured by some penalty function? Linear algebra, again, it'll be good if you have some comfort with these ideas. And we'll go over some of the basics as we go over things like PCA. I've also included a little bit of review of probability, but the assumption is that you've probably seen some of the basic concepts in probability, the central limit theorem, before this, which of course leads us to questions of statistics and the all-important aspect of hypothesis testing. Those skills I'm largely assuming and not going to be developing, although I will a little bit. The real thing I'm going to try to communicate in this course is focusing on the skills of computer scientists. And so the way we're going to do that is by solving lots of exercise in Python. In addition to pre-watching these lectures or watching these lectures prior to our actual meeting times, we'll then be spending our meeting times drilling coding exercises, as well as getting at some of the conceptual understanding of what's going on. The basic topics we're going to be focusing on things like defining functions, assigning variables, calling methods of objects. This is where we kind of get at the dot notation that appears in a lot of programs in Python. How do you control the flow? How do you interrupt it? How do you trigger error messages? Things like this, and other basic tasks. The idea of this course is that we're somehow trying to glue together large sections of van der Plas's Python Data Science Handbook with the sort of early fundamentals of Guttag's Introduction to Computation and Programming, which I'll sometimes call the MIT book. Van der Plas assumes you know these things, and then Guttag teaches those things to you, and much more. So I already mentioned that both of these things need to be balanced out by what I'll call the X factor in data science, which is domain-specific knowledge. So we've already got skills, math skills, statistics skills, nunchuck skills. Sorry, I had to make that joke, but also programming skills. But eventually we want to apply this to something. And what is that something? Well, it depends on what we're looking at. Some of you in pure math research, maybe you'll want to write some code related to, elliptic curves or something in algebraic geometry. And again, this is something you can do in Python just fine. Or say you're interested in public health. We want to understand measles, or now, of course, coronavirus. For the final project, you're going to be picking a particular topic, which is somehow tethered to reality. And it's going to require that you learn something about that project. I've had people look at sports data and also fluctuations in energy demands and things like this. You have to learn the specifics of your project in order to speak intelligently on that. So when I was an undergrad, I caught one of the last iterations of a course called 6001. This was a really wonderful course developed by Gerald Sussman and others at MIT that ran essentially unaltered for 27 years. That's very surprising considering how rapidly technology changes. But eventually I asked Gerald Sussman, like, why are we phasing out Scheme and turning to Python? And he explained to me that, for decades, it was somewhat reasonable to expect that you could teach people the very basics of syntax and definitions and the architecture of the language. You could go through a course where you build up all the things which go into really working with a computer. How do you interpret statements? How do you, build bigger and bigger projects on top of very basic things? The truth is that we now live in an era where there's now so far that we need to go that we can't reasonably expect people to start from the very, very basics of, let's say in the extreme, manipulating ones and zeros to showing off flashy graphics which illustrate what a neural net's doing. That's just a bridge too far to cross. And increasingly, as we move into the future, we're going to have to realize that some people are just not going to really understand what are the under the hood fundamentals of how a CPU operates and things like this. Instead, we're going to have to just be handed in a sort of ecosystem of packages which has already been written for us. And we need to basically poke on it and try to figure out how it understands just based on interacting with it. And so that ecosystem has already started to emerge in Python. In particular, we have things like NumPy, which is in many ways the replacement of MATLAB that's available underneath Python. It's good for dealing with homogeneous array-based data. You want to think of vectors of numbers. We have pandas, which is the manipulation of heterogeneous labeled data. So these are working with data frames where we have people's names, addresses, incomes, and all sorts of different data types, all stored in a big table. Of course, SciPy is great for common scientific computing tasks. We won't do much with it, but we will use some of the packages available there. And then, of course, Matplotlib, which is the best way at generating really publication-worthy graphics, which allow us to visualize our data. And then finally, the thing which most of us are going to be really interested in and which will occupy most of the second half of the course is getting at some of the basic methods available underneath the scikit-learn package. This is the sort of umbrella package for most of your machine learning methods. For some people who want to work with sort of an interpreter on their home computer, they might like using IPython, but we will largely use Jupyter notebooks because it's a nice browser-based way of doing interactive programming. And additionally, we can write little bits of HTML, Markdown, and even LaTeX, which is what we need to typeset mathematical equations. Essentially, all of your homework assignments are going to be Jupyter notebooks. And so that's going to be a great start. And it's also getting at this idea of we're working directly with something and then just sort of poking and prodding it through the browser. And in fact, these lecture notes are all made using a Jupyter notebook. All right, so there's the motivation, a little bit of the history of the course, but let's get at some of the basic ideas of computer science. And in this case, the question is, what is a program? So one way of thinking of a program is that it's a sequence of definitions and commands. So there you declare your terms, and then there you tell people to do things using those terms. Those are the definitions and commands. Now, what makes a program a Python program is that the question is, can the sequence of commands, definitions commands, be understood by what's called a Python interpreter? So you can think of this as someone who speaks Python, but it also means something specific about what is working in your computer, which takes in strings of definitions and commands written in the Python language, and then translates that into zeros and ones, which operate on the base level of your computer. So what is a definition? A definition is simply a way of naming something. So for example, we can call a name a number using a sequence of letters that's easy for us to speak aloud. So here I've just created a code cell inside of our Jupyter Notebook, and I can assert this definition that PI, that string of letters on the left of the equal signs, should have the value 3 by typing in PI equals 3 and then hitting Shift Enter. You'll notice that this little number here to the left just updated to indicate this was the first run code cell, and that now this command is in memory, or this definition is in memory. So what this expression does is it assigns the value 3, which we think of as the integer, the first odd integer greater than 1, to the expression that uses the English letters PI. Command, on the other hand, is an expression that can be evaluated immediately in a Python shell. And so you want to think of our code cells here as being a Python shell. So if I hit Shift Enter and do PI times 4 equals 12, then that seems to be correct. And so if I were to rename PI to equal 4 and run this again, it would now tell me that PI times 4 is 16. So what's happening there is the Python interpreter is reading that expression from left to right. It says PI, I don't know what PI is. But I have something in memory that tells me what PI is. It's equal to 4. And then it populates that expression PI with the value 4. And then it says 4 asterisk 4. Well, Python is written in such a way that asterisk stands for multiplication. So that's 4 times 4, which then returns eventually the value 16. So this is all part of something called the read, eval, print loop. Your program, your Python interpreter is reading, it's evaluating, and then producing that again until the loop ends, and eventually ends in this case with the number 16. All right, so you can see back when PI was 3, when I ran this lecture earlier, it said that pi plus 5 is 8. Well, now that we've updated PI to be 4, we now have that PI plus 5 is 9. So we now know that Python knows what to do with asterisks and numbers. And it even color codes this. So numbers are green, and these sort of commands are purple. And in black, I just have sequences or strings of letters, which have hopefully meaning they've been defined. So if we go through some of this and we rerun it, so imagine we've got PI equals 7, and then we go on and we write again that PI equals PI plus 1. So this is a situation where I'm now reusing a term on the right, which I'm trying to define. Now, normally in math, that would be horrible, because what this equation, if I read it sort of statically, instead of trying to interpret in an ordered way from left to right, is that if I were to have something like PI equals PI plus 1, it'd be equivalent to saying, at least mathematically, that X equals X plus 1. But what does that mean? Well, if you just do the little math and you subtract X from both sides, you'd be led to the conclusion that 0 is equal to 1. So in essence, if you try to interpret Python expressions as math equations, you'd be in trouble and led to all sorts of contradictions. Instead, what you want to think of this as being, I have an equal sign and I have variables on the left, and then I have expressions on the right. And when I evaluate a value of an expression, I can go back in memory. And so I use older values of pi in this case. So for example, all right, so that's pi equals 8. Notice that if I run this now as pi equals 8, and let me go ahead and I can use my little hashtag symbol to comment out. So here I have pi equals 8. That's what's done with this print command. But now let me go ahead and comment out that, and then just evaluate this expression, pi equals pi plus 1. Notice there's no error. It prints 9. And what's happening there is that when this command, this print pi command is evaluated, it looks into memory and say, what is pi? And then it populates up and it says, pi is equal to pi plus 1. But then that pi plus 1 was on the right-hand side, and it asks, well, what is that? And then it goes back to last time I ran this, which was when pi was equal to 8. And there the loop stops, and everything populates back up, and we have a expression that doesn't make any mistakes or errors. It's just it's got a good definition. So all that is good, and that just illustrates some of the differences between Python and math. But of course, we can do a lot of the basic things that we want to do in math, like addition and subtraction and multiplication and division, all using Python. I mean, after all, if this $1,000 plus computer that you have here should certainly be able to do the basics of a calculator. And so those are the common expressions for them. Exponentiation, so where I want to look at like 2 to the 5th, which is 32. I need to write that as 2 * 5. And Python will understand that that means 2 raised to the 5. And of course, let me take numbers which I would normally have no, well, let's just do 3 raised to the 3. All right, any guesses for what that is? Well, you can just go ahead and hit Shift Enter. It's 27, so 3 cubed. Makes sense, all right, because 3 squared is 9, and then times 3 again is 27. What about 4 raised to the 4? It's 256. All right, so again, maybe if you think a little more carefully about what that all means, it should hopefully work out. Now, you may realize that there's another way of maybe writing exponentiation, which is just use this caret symbol, the thing that points up. All right, it doesn't like that, so you need to be cautious of what that means. And so I leave it to you to now try to figure out what is that? What does this caret symbol mean mathematically? But let's go ahead and leave this back for future iterations of ourselves so that we don't get too confused. All right, so I want to invite you to take a moment, pause the video, and maybe and try to figure out what this / which looks like when we go to https:// // But here you should think of it as divide. So what does divide do? All right, so if you look at this here, you'll see a cell which you can freely manipulate as you like. So imagine I do 6 divide by 4. Get 1. What happens when I do 6 divide by 3? Get 2. And let's see, maybe I should try that initial expression, 5 divided by 2. All right, so have you figured out what this divide command does? Maybe one more will help. Let's do 10 divide by 3. 3 again. And then I think if I could put in 12, hopefully you'd see what it does, and then maybe check in 11. All right, so hopefully you figured it out by now. The divide symbol takes ordinary division and then drops the remainder. So it looks at the maximum number of times the number on the right goes into the number on the left. So 3 goes into 11 3 times, but with remainder. All right. So let's see, yes. So part of this issue of how to, syntactically express basic equations in math actually had a recent revival in a New York Times math puzzle that kind of, maybe you'll see it on Facebook or other parts of the internet where people debate, what is this expression equal to? So 8 divided by 2 times 2 plus 2. So you can think for yourself for a minute, what is that equal to? Well, let's go ahead and see what Python thinks. So I've gone ahead and written this a couple different ways. And I've gone ahead and used our variable assignment. So I've said, let's say answer 1 is equal to 8, all right, divide by 2 times 2 plus 2. That's answer 1. And then, I've also flirted around with what happens when I do divide. It's a similar thing. And then what happens when I do this without any parentheses? That's what happens with answer 3. And then let's see what happens when I just do 8 divided by 2 times 4. So let's see what you think this should be. All right, so what happens here, and you might be a little surprised at some of the answers, is that we've got a situation over here with answer 1 where it seems like what it did was it basically looked at this very first expression, so it's 8 divided by 2. It evaluated that to get 4, and then it did 4 times whatever this value was inside of the parentheses. So that's 4 times 4 gives you 16. But alternatively, you could have done something like just to write it down here real quick. So what about 8 divided by 2 times 2 plus 2? So this last expression, and again, when you're working with a code cell and you don't have variables or print statements, it'll return whatever this last thing is. We'll say that's 1. And I'll confess that, when I first read this expression, I thought, oh, yeah, maybe it's 1. All right, now why did I think this? Maybe in school you'll remember PEMDAS, P-E-M-D-A-S, which tells you that the order of operations should be parentheses, exponentiation, multiplication, division, addition, subtraction. So what I thought that meant, PEMDAS, was that, all right, well, if I have parentheses, then I know how to evaluate that. That means this expression here, 2 plus 2, that becomes 4. Done. So now I've got 8 divided by 2 times 4. How do I evaluate that? Well, PEMDAS, I thought it was MD, that's multiplication before division. So if you take the multiplication before division, then you take 2 times 4, it's 8. And then 8 divided by 8 is obviously 1. Turns out that's not how PEMDAS works. In fact, the way PEMDAS works is it says that, parentheses, so multiplication, division, and addition, subtraction are on equal footing. And the way you decide, you break ties, is by reading from left to right. So even ordinary, language and math expressions that you'll find on Facebook and such, still there are conventions, and you need to understand what these conventions are. And in this case, it's the same convention that Python likes, which is that you read from left to right. So in particular, once you've done this parentheses, 2 plus 2 becomes 4. You have 8 divided by 2 times 4. And that's exactly what's happening inside of answer 4. And so we can see, just again, double check, that Python interprets this as 8 divided by 2, which is 4, and then it multiplies because division was the first thing it encountered reading from left to right. All right. So that hopefully clarifies some of the sort of nitty-gritty details about how mathematical expressions are interpreted by Python. So let's get to our next sort of core lesson today, which is that functions and data types are sort of some of the key things that you need to master as we move through this course. So first of all, we already understood some basic examples of definitions like pi equals 3. And then we also understand some commands. Right now, the only commands we know are the print command and also some arithmetic. So addition, subtraction, multiplication, division, and exponentiation, and a few others. But if we could only work with these basic operations, we wouldn't be able to get very far in Python programming. And so what we need to do is learn how to abstract or put into containers sequences of commands and definitions, and then just put it all inside of a black box, which we label with a function name. And functions are basically going to be things which take in values and output values. But in Python, both the input and the output have what's called a type. So let's get into that. So first of all, the way you want to write a function in Python is you need to write def space and then whatever you want to call your function, which it's going to automatically highlight in blue because it says, this person, our user here, is defining a function, and this is now a new special name. You want to think of it almost as a spell, which you can cast. And then once you've got your function name, parentheses, you provide an argument. And this argument is just like you have in math class, f of x or g of x. X is just a variable. And right now, you don't need to specify what type it is. Now, the one thing you do need to do that you don't normally do in math is instead of using an equal sign, you need to use this colon. So that colon is really important. If I try to run this, it's going to give me a syntax error, invalid syntax, and it's going to point that something's missing here. What's missing is I didn't put in a colon. Now, the other important lesson in Python is that space is syntactically meaningful, meaning if I try to define my function like this, I'll also get an error. But again, Python's really friendly. It tells you indentation error, expected and intended block, indented block. And it points to exactly the start of this expression. So let's go ahead and put both of those back the way they were before, where I had it indented. So what happens here? So my function takes in x, I don't know what x is, and then it defines a new variable, y. And y is going to be equal, again, it's going to have some value on the right, 2 times x. And then to let it know that I need to spit out y, I need to use the return statement. And this is really, really important. Make sure you use this return statement. Now, functionally, we'll see that everything looks the same and works the same if I use print. But it's very important that for the homework, you don't use print, unless I explicitly tell you you can. All right, so let's imagine what happens when I feed my function a number, like 55. It does what you expect. It takes in 55, multiplies it by 2, and then returns that value. But as you can see, I had a weird thing where I also had quotes. So let's see what happens if I use quotes around 55. I get another thing with quotes. And that's because this function is flexible enough to handle a variable x whose value is of varying type. Obviously, numbers are going to be in type, but also strings, which are basically ways of writing expressions like I am a cat. And what this function does is it repeats that statement twice. Let's try to understand a little bit better what's going on here. But maybe for future iterations of myself, I'll go back to my function applied to 55. So one of the things that we saw, and of course in an early iteration, I used womp instead of I am a cat, is that we've discovered a little quirk of Python, which is that this multiplication operator, star, behaves differently when we try to use the integer 2 and the string womp, or I am a cat, or string 55, or quotes 55. And that's because the object 2 and the object womp with quotes have different types. And so one of the key things to understand is that in Python, everything has a type. Even though it can be very flexible with how to interpret things with different types. So part of our sort of glossary or just learning about the mechanics of Python is you need to understand there are two basic sorts of types. There are things called scalar types, which are indivisible, and then there are non-scalar types, which have internal structure. You want to think of this as kind of the classic scalar versus vector. Vector consists of lots of little entries with numbers or scalars in them, but scalar is just a single number. So one of the key lessons of Python is that an object's type dictates what you can do with it. Can you add or subtract or multiply or divide or what have you? But moreover, a lot of these basic operations, like the multiplication operation, is overloaded, which means that it behaves differently depending on the type of the objects involved. We already just saw that 2 times a number just does usual arithmetical multiplication, but 2 times a string repeats that string twice. All right. So we already saw that we can take in an integer n and a string and produce a new string that repeats it n times. Maybe we can do other things. Can we multiply or exponentiate one string by another? Let's just go ahead and see. So one thing is that we can add 2 strings using the plus operator. Put a space there. It's then going to read that as a single string, but now with a space inserted. What happens if I try to do maybe times? It generates a type error, which tells you I can't multiply a non-integer of type string. So basically, that doing bow times wow is not good. But if I were to do 3 times wow, I would get wow, wow, wow. All right. So this is all sort of examples of things that you can do where you should just play around with it and see what happens. And try to read the message and see if you can figure out what the message means. Half of programming is just reading error messages and trying to decipher how to fix your code. All right, so I mentioned that there are scalar types and non-scalar types. So what are the basic scalar types? Well, there are 4. We have int. This refers to integers like 2, 3, 7, 39, 42. There's float. These are the things that represent real numbers like 3.14159, 26, and so on. There's also bool, B-O-O-L, which represents conditionals such as like true and false. This will become more important in our next lecture when we talk about conditionals and loops. And there's also the none type, which is just sort of the type when we don't know what else to do with it. And I'll try to show you an example where none appears. So one important thing to note is that when it's possible, you can convert between objects of different types. And so this is especially useful when we do some of our first interactive programs where we use the input function. So let's see what happens here. So let's imagine I go ahead and like have a so radius equals int input enter a radius. So let's just go ahead and run this code and see what happens. All right, so programs, again, you want to read from top to bottom, left to right. So what happens when I hit shift enter in this code cell is that it said, okay, radius equals, all right, I'm defining a new variable called radius, and it's equal to whatever's on the right. All right, int. So what int means is that it's going to take whatever's inside the parentheses and try to convert it into an integer. That means I'm typecasting. I'm casting it of integer type. But what am I typecasting? Well, I am typecasting whatever the value of this expression is, which is input, and I have now a string written inside of that input, quote, enter a radius. And so what happens is that input enter radius creates a new box. And here it is patiently waiting. You can tell it's waiting because there's a little asterisk here to enter a radius. So let's say I enter in 5 and hit enter. And it now prints a message. And that's because one of the later commands prints a message. And then it has separated a comma and what that area is, where area is defined as 3 times the radius. And of course, radius is just defined in the line above. So what happened here was I said it assumes that pi equals 3. That's right. This was the string I wrote right here. Your area assumes pi equals 3. Hence your area is, that ends the string, has a comma, and then it just has area. Now, area is 3 times radius, which is going to be an integer, which is 3 times, in our case, 5. But of course, this is the wrong formula. I need to upgrade this because we know that really the formula for area is 3 times radius squared. So let's go ahead and run that again. So in that case, it takes the radius squared, 5 squared is 25, multiplies by 3, and then returns that. Notice I've got sort of an extra space here, so I don't even need necessarily that extra space there. So if I run this again, 5, things look a little bit nicer. Suppose I wanted to add a period here. I could add another set of quotes, and I can do single quotes or double quotes. Again, and now again, I got this automatic space here. All right, and that's in part because I'm using these commas here. Another way of writing this is to write plus, and if I wanted to take my area, which is a number, an integer, turn it back into a string so that I can print it as a string. So I get this, and you'll notice subtle things have changed, like the spacing that was there because I used a comma to separate this list of objects is no longer there. And so now I'm going to put back in my spaces. And so now I get something like that. I guess I don't need that period. Boom. There you go. That looks nice. So you'll now move into your live exercises, but you can ask yourself, well, before I had essentially controlled the way the user could enter in data by always typecasting it into an integer. But obviously there are non-integer radii. So how do I instead make this a float? So just try to imagine, well, if I had a int parentheses, turn things into integers, and I had str parentheses, turn things into strings, then it stands to reason that if I were to take this code, I can just copy it, and then change int to float, Suddenly I could do something more interesting. So like 2.5. Suddenly I have a non-integer, but a float area. And everything seems to be working out appropriately. Aside from the pesky detail that pi is not equal to 3, but that's something we'll talk about later. All right. I look forward to seeing you in class soon.